Alright, this is lesson 7-3, solving two-step equations with fractions and decimals. So, a two-step equation is nothing new to us, so it shouldn't be too hard for us to get going. Something that may throw us off is we have fractions involved in our equation. Still the same process, I'm going to do the opposite function with the same number to both sides of my equal sign. So to start things off, remember I work backwards, so I'm going to add 6 to both sides before moving on to my next step. So carry these down 2/3 n, minus 6 plus 6, that cancels out, equals 22 plus 6 to get 28. And so my next step is going to be doing the opposite function of whatever's happening to my variable n. In this case, I'm going to be multiplying by, or I'm multiplying by 2/3 right now, so I'm going to be dividing by 2/3. If you guys recall, we don't ever divide by fractions, we actually multiply by the reciprocal. So what I'm going to do is, I'm going to multiply by the reciprocal of 2/3. Remember, the reciprocal is flipping over the fractions so that when you multiply them together, they will equal 1. 2 times 3 is 6, and 3 times 2 is 6. So 6 over 6 is equal to 1. So I'm going to multiply by 3/2 on both sides. Like we said, this is already 1. So 3 times 2 would be 6 over 6n, or just n, equals 28 times 3/2. Now what I can do is, before I even start going, I can do this, and I can cross off or cancel out a 2 factor from both 2 and 28 to get 14 times 3 over 1. And that leaves me with 14 times 3 is 42. So my answer is 42. So this process shouldn't be new to us. However, something else though that this lesson teaches us is we can have a shortcut to kind of make life easier for us. So take a look at this problem. Three-fourths p minus 7 equals 11. Now, I can go ahead and solve it like I did before. Or, before I even start working with my fractions, if I don't like that, I can multiply everything by 4. What that would do is, that would take away my fraction, because if I multiply this side by 4 over 1, and I multiply this side by 4, what I'm doing is, I'm allowing this 4 and this 4 to cancel out. And so what I'll be left with is 4 times 3, which is 12 over 4. Or if I cancel these out and take out the factors here, what I'm left with is 3p. And so now I don't even have to work with a fraction if I don't want to. Now the thing to keep in mind is that whenever I multiply by 4, it is to this entire side. So I'll have to do 3p minus 4 times 7 is 28. And then over here, 11 times 4 is 44. Is 44, and so I can substitute that value in right here. So now my problem reads 3p minus 28 equals 44. And what I can do is add, or the same process as before, add 28 to both sides. Add 28. 3p equals 3p minus 28 plus 28 would be would cancel out, so that would be 0. So 3p equals 44 plus 28. Looks like should be a 72. All right, so 3p equals 72, and then of course I do the opposite of multiplying by 3, which would be to divide by 3 on both sides. Leave me with my final answer of p equals 24. So that the first step, if you go back to the original problem, I had 3/4 p. If I multiply by my denominator for the entire problem through the whole thing, then I can not even have to work with fractions if I don't want to.